In this section, we are going to look at how to create a lottery application using a smart contract. This, I would say, is the next level of what you are going to do in Solidity, because whatever you need to know about Solidity programming language, its variables, functions, interfaces, libraries, abstract concept, how to call one contract from another, all the basics that you need to know about Solidity programming is done with already. Now, in this particular section of the course, you are going to culminate all of this knowledge that you have gained and put it into a working application, a production level application that you can build based on the smart contract. Right? By doing this, we'll get into a lot of understanding of how to use the variables, where to use a function, when to use payable functions, and all of this stuff will be cleared to you. Now, before getting into this program, I would like to tell you that in this kind of hands-on sessions, one we are going to create is lottery and the other one is Amazon, right? So in these kind of hands-on sessions, I'll be asking you a few questions before writing anything or before deciding what kind of variable type to use and things like that. So I would like you to pause this video and then think for yourself what would be the best case scenario, so that later when you look at my code and how I am implementing it, you might want to contrast whether your ideas worked out or whether your view is better on things. Just because I'm coding it does not mean this is the best way to do things. There are multiple ways to do the same things in programming languages, right? So if you start doing this, if you start thinking for yourself what variables and what functions to use, etc., you will get your thought process widened also, right? So with that, you will become a better programmer, and that's not only for Solidity, for any programming language in the world, right? So with that said, let's get into this lottery creation itself, right? So why have I chosen this lottery page as the one that we need to do in Solidity is because the existing lottery, traditional lottery applications has a lot of issues. It has an intermediary who is deciding the winner, etc., right? So what happens in a lottery? What is the traditional method of how lottery works is there is a company which creates this lottery, right? And multiple people, one, two, three, let's say these people are investors or players or participants, we'll call it. Okay. So let's say 100 people are investing into this lottery. They all give $100 each. So the total is about $10,000, right? So what this company says is that once we collect all of the $10,000 from these 100 people, 100 players, we will choose one person in random, right? We will choose one person in random out of these 100 people, and let's say it is the fourth person. This person is going to get the entire $10,000, right? So it's like a probability, randomness, and all of this is involved when it comes to a lottery application. I hope you have seen lottery or at least played lottery in any one part of your life, right? So this is how a lottery application works in the traditional manner. The problem is when they say we are going to choose someone at random, do we really know that this randomness is working? Is it truly random? What if they have a bias towards, let's say, first or second or third investor? And what if they pay this money, they choose this random function in a way that it skews towards these kind of investors who are their relatives or friends or anything, right? We do not know. These things are completely opaque to us, and we do not know the algorithm running in the company, right? So the basic point is the traditional lottery has a lot of scope for manipulation by the company, right? Now when you bring a smart contract into this, you will get complete transparency over what is happening in the code, right? So because blockchains are transparent, we can get to know what is the smart contract code running in the lottery application, right? And once you invest, because of the immutability property, nobody can say you have not invested, or once you invest, the logic is not going to change also, right? So because of these kind of advantages, a smart contract can be used to eliminate this company and do the same stuff inside the smart contract itself. The one that is helping us here is that a smart contract can hold money as well, right? So we'll start with that and see what all we need to create for a lottery. So I'll get into this remix and create a new file called as lottery.xml, and within this, as we all know, it should be pragma solidity 0.6.1. I'm using the latest version to create this. Let me create a contract and call it lottery. So within this, first let's write out some comments as on what is the logical flow that should be happening in our contract, right? Now, the first thing that should happen in my lottery, you also need to think about this logic of lottery inside your mind, and then you can look at the logic I am creating also, mix and match and see if you have any better features to add. You can definitely try it out, right? Now, coming to the lottery part of it, the first thing I wanna do is to invest money, right? Invest money by players. So anyone in the world, player can be anyone in the world, right? So anyone in the world should be able to come to my contract and call a function so that he can send money to the contract, right? That is the first part where people invest into the contract, right? And then we should have a function to see the current balance. Okay, so current balance of the contract itself, right? Then whenever the owner clicks a function, it should do the following: select a player in random and send the total money in the contract to the player, right? So these are the things I want to do. Yeah, there's nothing more than this. Why do I have something called as the owner is because if I am the person who is deploying the contract, I want to be the owner, or we can call them manager, right? Owner means he owns the logic also. We'll call them manager because there should be a trigger in any smart contract that you write. Yeah, so I should be able to click on a button and hence it calls the winner. But I cannot ask any person in the world to do that. I cannot make it public because what if someone manipulates when to call this trigger, etc. So the lottery company also has a person who does that on 30th of every month or something like that, right? So similarly, I want a person to click the button, but the important thing is he should not be able to influence the random number. That's all, right? The randomness is there in the smart contract. He is just a volunteer or an employee kind of a person who only clicks on a button. He cannot decide or manipulate the result. Yeah. So that is one thing that we need to keep in mind. The contracts that we create cannot work automatically. There should be a person who starts it, deploys it, clicks on it and everything, right? So that will be the person called as manager here. Okay. So this is how I would suggest anyone in the world to start with any contract that you are writing. Yeah. You write comments and then try to implement these comments one by one as functions. So like this, your project keeps evolving one by one, right? Very important to do that. So before that comes the constructor, right? In constructor, I want to set the manager, correct? So manager will be decided first itself, so that if it is running in the constructor, nobody can change that and things like that, right? So that is why I want to set it in the constructor. One additional thing that I wanted to do, right? So let's get into this. Take one comment at a time and convert that into a functionality by writing functions. While writing functions, you will also see what variables are required to do this, right? Okay. Now, first writing the constructor for this, uh, reimagine, go back to your solidity variables and functions and think about how you write a constructor, right? Do you remember the syntax and what needs to be done, right? You can pause this video and go back, try writing it yourself and then come back and look at my code also, right? Now, a constructor starts with the keyword called as constructor and any inputs if we have. In this case, we do not need any inputs from the user, right? Of course, we need the manager's address, which can be got in a different manner, right? As we know, the person who is calling or deploying the contract is going to be the manager here in our case, right? So if you remember the global variables, we know message.sender is going to give you the person who is calling, the address of the person who is calling this function. Yeah. So I'll do manager equal to message.sender, right? So that is how this construct is going to be created. But I haven't created a manager yet, right? That's why it says undeclared identifier, right? So I need to give a address. Let this be public. Let anyone know who is the manager of this contract and things. That's not an issue at all, right? So once you create this, the constructor will send the message.sender to the manager, which means if I deploy the contract, I am going to be the manager. Okay. So that's about the constructor. Second one is the invest money by players, who anyone in the world will be able to do that. Okay. Now pause the video, think about how you can make people invest into the smart contract, which means how can people send money to the contract, correct? If you are thinking of this, then a payable function is what allows people to send money from an external owned account to the smart contract, correct? So let me do that by calling function. Let the name of the function be invest to make it easier to read and things. Now it will be a public function because anyone in the world should be able to do it. Also, it will be a payable function because only with a payable function you will be able to send money to the contract. Correct? That's it. So the function body does not need anything because you are just using the payable function, which means if you send 0.1 ether, it will be automatically added to the balance of the contract. Correct? But here I want to keep a track of who all invested, correct? So if you go back to this, I need to know who is 1, 2, 3, 4, their addresses, right? Only then I can choose one in random and send money to that particular person, correct? So here I want to keep a track of who all invested into the contract. Okay. Now I can have multiple options to do this, right? But I think an array will be the better thing to do. Think about it. An array of addresses, right? So whoever invests, I'll get his address, store it in a dynamic array, right? So how can you set a dynamic array into this? By saying address, open bracket, close bracket, because you do not know how many people are going to invest, right? You can say there will be maximum of 100 or something, but I am keeping it free. Even 500 people come, there is no problem, let it be, right? So address, then of course it will be public, and I'll call them players. Okay, so these are the players. So when someone invests into the lottery, right, I want them to be added to the players array. So how do you add items into the dynamic array? Think about it. Now players dot push of who is the person who is going to be getting into this. It will be the message dot sender itself, right? So that is how you invest money and then get added yourself into the players array, right? So that's how this invest function works. Think about it. In fact, you can also create a struct of it, a player, and you can say this is his address, this is how much he invested. But in a lottery setting, right, um, you can do all that, but I don't want to restrict anything. If a person gives 1 ether or if a person gives 3 ether, I am okay with it. Anyway, the total balance is going to be given to only one person, right? So even if I don't keep a track of how much each person is giving, that's fine, right? Going by the logic of it. But if you want, you can do that as well, right? Not an issue. Now, second comment is done with, right? I want to keep a track of all invested. That's also done with. Okay. Now, I want to get the balance, the current balance of the contract, which we have seen while doing it in the functions and variables itself. So I'll call this get balance, right? It will be a public function. It will be a view function because I'm going to just read the variable. It will also return something. What will be the returns thing? It will be a unsigned integer because balance cannot be negative, right? So here it's going to return address of this dot balance. So we have seen this is how you get the balance of a particular contract, right? So I want to do this. Okay. Now comes the logic of selecting a winner. Okay, selecting a winner among all the winners that are there in this contract. Okay, all the players that are there. Right. Now to call this, the manager clicks a function. Okay, it should select a player in random and send the total money in the contract to the player. Okay. Now let's look at the concept of how this winner is created. Okay. So go back to this and I'll explain how we are going to create it. Right. First thing is I'll create a random number. Okay. The random number can be anything. Okay. So let it be 134986. So this, it can be 134986, or it can be 2497, or it can be, let's say, 8,099,7235, anything, right? It can be any of these numbers. It's just creating randomly. Okay. Now there are only, let's say, 10 players. Okay, 10 players are there in the players array. Okay. So what does I mean by an array? There are 10 slots. Correct? 10 slots. Now, if this number comes, how do I allocate that to a particular person? How do I match that or map that to a person in this array is the question. Right? Now for that, I can use a modulo operator. Okay. So for people who do not know what a modulo operator is, it is the remainder of a division. Okay. So what happens when you do 5 divided by 2? It is 2.5, right? But when you do 5 modulo 2, that means 5 goes in 2 twice, right? What is the remainder here? It is 1, correct? Same way, if you do 10 divided by 4, let's say, the answer is 2.5 again, right? But the remainder here will be 10 divided by 4, 8 goes twice, and then 10 modulo 4 will be 2. Okay. This is how modulo function works. Now imagine I am saying that this modulo can only be, right, can only be 0 to denominator minus 1. Okay. 0 to d minus 1. How am I saying that? Okay, take the number 4 itself. Okay, 4 tables, right? When you divide 0 modulo 4, okay, the remainder is going to be 0. 1 modulo 4 is going to be 1, correct? 2 will be 2, 3 will be 3, and when again you go to 4, it is going to become 0, correct? 4 divided by 4 is 1, there is no remainder. Yeah, 5 when you do, it's going to become 1. 6 is 2, 7 is 3, 8 again will be 0, right? That's why I'm saying it can only be between 0 and the denominator minus 1, correct? So this concept can be applied here also. If I say random number is 134986 divided by 10 or modulo 10, what will be the answer? It will be 6, correct? 2497 modulo 10 will be 7. So 2490 will go in 10 and 7 is the remainder. Here modulo 10 is going to be 5, right? So this is the concept I am going to apply here. I will find a random number, modulo that by the total number of players, so that it forms anything between 0 and 9. If there are 10 players, if there are, let's say, 18 players, 18 players, right? The modulo will give 0 to 17. So I can easily map the number to something. If it comes 3, this is the person, right? If it comes 9, this is the person, right? That way. So this is the concept. If you want, you can go through this again and revise this entire thing. Let's get into the coding portion of this. So here what I need to do is create a function called as select winner. Okay. Here I need to make it public, okay, and create the function. right? Within this, I'll write the steps that we just discussed, and then we can code each and every step so that you get a clear idea, right? So first I have to select a random number, correct? Then modulo 8, right? Modulo 8 with number of players, okay? As I write, you can keep thinking what all programming concept that we learned till now can you apply here and now, right? Modulo with the number of players. Then what you need to do is map the remainder to a index in the array, right? Map the remainder to a index in the array, which means if the modulo answer is 3, right, you'll go to the array 0 1 2 3, right? The fourth person will be the winner. That way you have to map the remainder. So once you map the remainder, you will transfer, right, all the money in the contract to the address in the array that is selected, correct? He'll be the winner, he'll be getting all the money, right? So that's the concept of selecting this winner and transferring the entire money to him, right? And then make the array empty. That's also very important, right? So players are selected. Once you invest, you become a player there. And then once one person has been selected as the winner from the entire players list, one person has been selected, that's all, your investment has gone, you have lost the lottery, right? So this players array has to be made empty again, only then the next set of lottery people can come in, right? So that's also one concept which we need to do it here, right? So I just delete this because we have made it in a different manner, right? Now the first thing is selecting a random number, okay? For this I am going to do a pseudo random number, right? I cannot bring in a randomness into solidity, because remember this, a solidity or any smart contract program in the world, right, lacks the concept of randomness. There is a feature of blockchain called as deterministic property, right, which just means it does not have any randomness. Today you do a plus b, tomorrow you do a plus b, it's always going to be the same answer, right? 2 plus 2 is equal to 4, that is universal, yeah. So for that reason, if you do 2 plus 2 plus a random number, then if you give A and B as separate inputs, right, uh, the answer will differ every time you call it, and blockchain does not support that. Okay, blockchain does not support the concept of random numbers or randomness, right? Now that's why I'm going to use a pseudo random number. Do not use this in production. Okay, do not use this in production. This is only for demo purposes. Okay, so I will also tell you, use oracles. So there is a service called as Oracle, right, which helps you bring data from the outer world into the smart contract world, right? We'll be discussing about oracles in detail when we look at some design patterns, right? But use oracles to find a random number, right? So what will happen is you will use a third party website or something to create a random number, input that random number into the smart contract if you want to do this in the production. Okay, the method that I am going to use, don't use that, because it might be manipulative by the miner or user or anyone in the world. Okay, anyway, so here I am going to create a random number, right? So let it be a unsigned integer, right? I'll call it r, okay, is equal to something. So if there is no function like random, right, in Python, in JavaScript and all, you can say random 1 comma 100, it will give you some random number between 1 and 100, okay? But in Solidity we don't have that, yeah. So I need to do something, take some variables and put it together to find a random number. Whatever I'm going to do here is just one way of doing it, okay? You can try your own methods, not an issue at all. So what am I going to do here in for the random number is, okay, first take some global variables, okay, then encode it, okay, hash it, convert to uint. That's all. This is what I'm going to use now, right? So for that, let me do first block dot timestamp. We have seen this global variable which gives a Unix timestamp, right? Then I'm doing block dot, let's say, difficulty, which is also a number. Also, shall we include the players? Okay, I'll include players dot length. What is players dot length? The number of elements inside the players array. Correct. Now, what I need to do? Take some global variables. I've taken them, right? Then I need to encode it. So to encode also, just like block.timestamp, we have something called as ABI encode packed. That is a global variable. So you can say ABI dot encode packed. Okay. So this will encode this entire thing like encryption, right? Then I want to use a hash function. So Ethereum uses Keccak 256. Just like your Bitcoin uses SHA 256, this uses something called as Keccak. So let me go with the same thing, Keccak 256, right? Once I do this, this is a hexadecimal number, right? But I want an unsigned integer. So to convert this into an integer, I can say uint of this, correct? So that is how I create a random number. Remember, don't use for production. This is not the way you create a random number. This is just one of the ways to make it look random. It's a pseudo random number I'm creating. Okay. Now, just to prove to you that this demo actually creates a random number, let me write another function. Okay, random function. Put this in there so that whenever we want, we can call that function. Instead of putting it directly inside a function, call from one function to the other function is also possible, right? I'll create function random. Okay, public, right? View, of course, and it returns a unsigned integer. Okay, just copy this, right? Just to copy this, and you can return this thing, right? Instead of doing it all inside select winner, I want to have it random because it makes it easier to read the code, makes it easier to see if it is creating a random number and remix, etc. Okay, so here what I can do is call that function. Okay, that is how I am doing the first part. So all the things that we discussed here, remember that, so that you are clear with this concept. Okay, next what I need to do is modulo it with the number of players. How do you do that? You can say uint, I'll call this index, right, is equal to r, which is our random number, modulo players dot length. What does this do? Players dot length is the number of players, r is the random number. So we wanted to modulo the random number with the number of players. That's what we did. Okay, map the remainder to an index in the array. I'll create a new address, a local variable, okay, to just call him winner. So address winner, okay, is equal to this index, has to be pointed towards a particular this thing. We saw the array, as you can saw here, a big array, and then you have to point at the particular location, correct? So for that, imagine how we need to do that, right? So you will call players of index, correct? So you have created a winner and said players of index is the winner of this contract, right? Now, the next one is transfer all the money in the contract to the address, right? So how can you do that? We know that it's recipient dot transfer, in bracket you will get the amount. Okay, so who is the recipient here? Winner is the recipient. Dot transfer the money to him. How much money? The entire balance. How do you find the entire balance? It's address of this dot balance. Address of this dot balance is what we need to do, correct? And then you have to make the array empty also, because we know this concept why we are bringing this in. Okay, to do that, what you're going to do is there's a specific way in which you can empty an array in Solidity. Let's see how it works, right? So I'll call players, that's the array name, is equal to new, right? New keyword, just like you when you want to deploy a new contract, right? You will create a new address array and put 0 inside it. Okay, so we'll come back to this error which shows here, but this is how you empty the array. Now what we are creating is, you are creating a new empty address dynamic array, right, and assigning that to the players. Okay, so with 0 elements of course in the beginning, right? This is one way you need to go remember this, right? Perfect. So till now the logic works. Okay, as in I create a random number, somehow pseudo randomly I create a number, then I assigned this to an index which is given by the modulo function, and to that person called as winner I am transferring all the money, right? Then why is this showing an error here? It's because any address needs to be payable if the smart contract has to send money to that address, right? So winner is not a payable address and hence it's showing an error. So should be address payable winner, correct? But still it is showing error because the players array is not payable addresses. Okay, so remember that the entire players array there might be 100 participants also, correct? Any one of them can be a winner. Okay, so I just need to make this address players array also as payable, right? Only if I do this, it's not going to give that error while transferring. Okay, remember function payable and address payable, right? So why is this showing an error? Here I created a new address array, right? So here I'll make it payable also. So once I do this, no errors in my contract, right? Let's deploy this, look at what is happening. If it is working fine, then we'll get into the next steps. Okay, I promise you that we are going to go much deeper into this, not leave it here, of course, right? So once I go into this, let me deploy the contract called as lottery. Okay, so all the functions we have got here. If you get balance 0, if you see the manager AFEB, that's my address, right? If you look at the players array, it's going to give me an error because there are no players now. And if you call the random number, this is what I wanted to show you. It's created a huge unsigned integer 256 number. Okay, this is one number. If I call random function again and again, it's going to give different numbers to me. Okay, so again call it, again call it, again call it, again call it. Only in Remix it will give you random numbers whenever you click it. In the actual production level application, this will not give you random numbers every time you click. That's why this is called as a pseudo random number, just for learning purposes. Okay, so Oracle's concept we'll see later, of course, right, during the course. But now remember this thing a lot, right? So the first thing I want to do is invest some money. Okay, I'll choose 3 players. Okay, A80D will be the first player, 6583 second player, 12080 will be the third player. Okay, so the first player comes, or 5 players also we can choose, doesn't matter, right? So the first player is investing 1 ether. Okay, so select this. This person wants to send 1 ether to the contract. Okay, so he will just say invest. Once it is done, you have to see the balance. It's 1 ether, 1 into 10 to the power of 18, right? Players of 0 is becoming 80D, correct? My entire logic works. Money has to go to the contract. Players array it has to push. It worked, no problem. Similarly, I wanna invest from other people also. Let's say 2 ether is invested by the second person, right? 3 ether from the third person. Where is it? Invest. 4 ether from the fourth person. You can also try it yourself, not an issue at all, right? 5 ether from the fifth person. So what is the total balance now? 15 ether. Okay, 1 plus 2 plus 3 plus 4 plus 5, right? Who is the manager? It will still be the same, no problem. So players of 1 is the second address, 2, 3, 4. It will be till 4 only. 0, 1, 2, 3, 4, right? 5 players. If I call 5, it's going to give me an error, correct? Okay. Random number is working. Everything is fine till now. So invest we have done. Get balance we saw it works. 15 ether is what it has. Random is also working. Now if I call select winner, correct, select winner, any one among these 5 accounts is going to get 15 ether, correct. All the entire balance will go to that person. Now 98, 97, 96, 95, 94, it will be easy for us to find out who is winning also, correct. So let me go to the manager account DAFEB and click on select winner, right. See if our logic works. Okay, so once I click on select winner and this function gets executed, right, here you can see that the 5th account 3CE3F is the one that won this entire 15 ether from the lottery, correct. So that's how this logic of lottery works. I hope till now everything is fine. You're understood the concept and things, right. If you have understood, that's fine. Otherwise you can go back, rewind and see for yourself how this is working again, right. Now we are going to get into some more steps, right. We have learned about require statements, we have learned about events, etc. So we are going to install all those things into this particular contract. Okay. So let me clear this, go back to the function. Now do you see problems in this entire code? There are, right. There are multiple problems. Out of this I wanted to take a few things, right. We have to add conditions. Okay, so you have this invest function, correct. For me, I don't want the manager. Okay, manager should not invest. Okay, first condition, right. Second condition, okay, second condition is that okay, manager should not invest, and then payable public invest is okay. Let me put one more condition here. Okay, call the person should invest minimum 0.1 ether. Okay, otherwise a person can just click on invest with 0 rupees also. He will invest 0 ether, and if he wins he'll get the entire thing. Zero investment, get anything. That's not how financial world works, right. I want them to minimum invest 0.1 ether. Or you can also do, he has to exactly invest 3 ether, right. 3 ether. I'll show you how both of these can be done, right. That's fine. When it comes to get balance, I don't want anyone in the world to know how much is the balance that's there in my smart contract today. Okay, so only the manager should see balance, correct. Otherwise any player can see how much people have invested, right. So I don't want that to happen. Next, random function is public, correct, but actually only select winner is calling that. For seeing the random number, it's fine, but it's an internal function, should not be allowed to be called from outside. So let me make this private. Make sense if you go back to visibility specifiers and everything, right. Okay, now who should be able to select winner? Only the manager, right. So only manager can call this function. So these are the conditions that I need in this contract. Otherwise, anyone can call select winner now. It is public and all, right? But we did not want it to happen. No, manager only clicks a function, correct? So I want to satisfy this. Only manager will call this function also. Okay, good enough. Now let me start writing require statements. When I write or before I write, you can pause the video and think for yourself. How do you write that? Okay, we have seen require statements already during Solidity. So either it will be manager should not invest. So I need require the message dot sender, right, not equal to manager. Otherwise I'm going to throw a error saying manager cannot invest, right. Wonderful. The person should invest minimum 0.1 ether. How do you do this? You will write require the amount that is sent to a payable function is called using message dot value. We saw in the global variable section. So you'll say message dot value, right, is greater than or equal to 0.1. You can say ether, right. It is not always way. The default is way. If you just give 0.1, it will be way. right? It won't accept only, right? But I can give ether also, just to make it easier. Okay, this I can do, and I can also throw an error here saying invest minimum of 0.1 ether, right? These are the two conditions I wanted, and I have created this, right? So how do you do exactly invest 3 ether? You will just say equal to 3 ether, right? So that's the difference, but I don't want it to be that way, so let me change it to 0.1 ether itself, right? Wonderful. So the first thing is done. Second one, get balance. I want only the manager to see the balance, right? So again require message.sender equal to manager. Previously we did what do you call, only manager can call this function. So previously we did manager should not be able to invest, right? Here only the manager should be able to. Okay, if this is wrong, if the message.sender not equal to manager, it will not go to this return, and hence nothing will be returned from this contract. It will throw any error. Okay, that one. In random I don't have any condition. In select winner I have a condition, only manager can call this function, right? So here also I will say require message dot sender equal to manager, and here also I will say only manager should be able to call this function, correct? That's all. So I have implemented enough securities required in this particular contract. Okay, now another improvement you can do is require message.sender equal to manager. Here also require message.sender equal to manager. We have learnt a concept of modifiers to reduce the number of required statements you are doing, right? For that, let me create a modifier. So I'll create a modifier and say only manager. Okay, so within this I need to copy this entire thing and put it there, right? So just cut it maybe, and then this will go back, and this will also go off because I have created the modifier, right? Remember the underscore that we used to give in modifiers, right? Oh sorry, this is in constructor, so it's here I have to give an underscore. Okay, so only do this. How can you implement this modifier wherever you want? You will copy only manager name and put it in wherever you want. Okay, so this is only manager should be able to get the balance. Only manager should be able to look at the select winner function also, right? So that's the concept of this lottery. I have implemented security checks. Let's check the security things that are existing in this contract. So let me deploy this from the first account as usual. Okay, I can see that this is the manager AFEB, get balance is 0, right? Players is nothing, and all of this. Okay, now let me invest from A80D. Okay, what this person is doing is investing 1 ether into this company. Can he do this? Yeah, transaction is successful, green mark and all, right? Next, the manager is trying to do. DAFEB is the manager, no? He is sending 1 ether. Okay, invest. It's saying no, you cannot say because manager cannot invest. Correct? This, where is that? This require statement got invoked. Okay, fine. So manager cannot invest, so second person comes in. Okay, he is trying to give 0.01 ether. Okay, invest. Here it will say invest minimum of 0.1 ether. This requires statement. Okay, now can this person see the balance here? Get balance. It's going to give a VM error, right? Only manager can call this function. That's coming from the modifier, right? Get balance. Then comes the select winner function, right? So can this person select a winner? Click on it. It will say only manager can call this function. Again from the modifier, correct? So now only my manager will be able to call the function called as select winner, right? Once it is done, go back, and the which person won this? Yeah, I think the first or second person, no idea. Okay, yeah, only one person invested. That's fine. So the logic works. We have implemented enough security things also into the lottery contract, right? Let's come into the next one. Okay, next step of doing this. Okay, only one thing is pending. Now the problem is this time also when we selected a winner, right? We were not able to see who won without looking at the balance. Okay, in the remix ID, if you look at, you have multiple accounts here itself, right? But in the actual production level application, what is going to happen? All the people are going to stay in different parts of the world. You don't know anyone. You cannot see their addresses or the balance that they have in each of the addresses in their wallets itself, right? You cannot. Yeah. So for this, we saw a concept of events, and emitting those events is going to let know the front end who has won and everything, right? So I want to emit an event whenever someone invests money into the contract and whenever someone is selected as the winner. Okay. So events to the front end. I hope we all understand the concept of events and emitting an event to let know the front end what is happening, right? Also, we saw that events act as a low cost storage in the blockchain, right? So first event I want to create is event invested, right? Or let's say player invested. Okay, let's come back to that. Another event called as winner selected. Okay, whenever a person invests money into the contract, I want to show the front end what is the address of the person and how much he invested. Okay, so I'll say address of the player, right, and event of the amount also. Okay, this is how you do variable name and give it a variable the variable type and variable name, right? Same way here also. Whenever a winner is selected, what do I need to do? Address of the winner, right? And I want to say how much he won also. Okay, these two things I want to give. So when will player invest come? After this, right? So you will say emit a player invested event and tell them who is the player, message dot sender is the player, and how much he invested, message dot value is what he invested. Okay, then winner, correct? Winner, here you will say emit winner selected. Who is the person who is selected? Message dot, so no, winner, right? So this person is the one who selected, right? And how much was transferred to him, right? Address of this dot balance. Now stop here, pause the video and think about what is the problem with emitting this event here. Okay, so think about it for let's say 1 or 2 minutes. If you get the answer, that's fine. I'm saying you cannot emit the event here, right? Not in a programmatic manner, but in a logical way this doesn't make sense. Okay, so think about it. I'll tell you that now, right? Okay, what happens is I am saying address of this dot balance, correct? That will give me the current address, right? So once you transfer, winner dot transfer all of the money to that person, and after this line, if you call address of this dot balance, it is going to be 0 only, right? So you can do two things. You can either take this address of this dot balance, put it inside a local variable, and then use the variable here, or the better thing to do or easier thing to do is just emit this winner selected signal, right, before sending that money, right? So this is an easier way according to me, right? So who is this winner and address of this dot balance is what you are going to give, right? So with that we have events also input into our lottery contract, right? So let's just play it again, final time, implementing all of the features that we have seen, right? Let's deploy this from the first account again, right? Deploy, and then you have everything. First account again 1 ether invest. Second account, oh okay, it did not change, is it? Fine. So first account 1 ether invest, second account 2 ether invest, third account 3 ether invest, fourth account 4 ether invest, fifth account 5 ether and invest, right? All of it is done. Now if I go to players and put 0, it's the first account, 1 second, 2 third, that way, 3 this thing, fourth account, right? So 5 is also there. No, 5 gave error. So there are 5 investors, right? And if you want to see who is the manager, you can see, because that's a public variable, anyone can see who is the manager. Okay. Can I see get balance? I cannot, because only manager can call this function, it seems. I'm not in the manager function, right? Fifth account. So if I go back and then click on get balance, it's going to give me 15 ether is there in the contract. If the manager tries to invest, it's going to see manager cannot invest. Okay. All the security features we had. Now we have to say select winner. Once you select winner, we are going to know exactly who invested. Okay. Oh, I can show you that also. Whenever you invest money into the contract, right? You can see, yeah, you invested. If you go to the logs, you can see the player invested event emitted, right? You can see the player. This is the address of the player, and he invested 4 ether, it seems. Okay. And if you go to this transaction, you can see player invested, this is the address, 3 ether, right? So that event also comes out. We can easily get to know in the website who are all investing and everything, right? You can change it according to only the owner should be able to see that and things like that, right? Next, okay, I have to select winner. So click on select winner, make sure it is in the manager account, right? Once you do this, previously we did not know who won, right? You have to go to the accounts. Now if you go to the event, you can see who is the winner. 8080F42 is the winner, and 15 ether he won, it seems, right? 80F42, you can go to this. 80F42 got 15 ether, right? So that is how you write a contract implementing all of the concepts that we tried out till now, understood till now, and make it a workable decentralized application. I hope this hands-on was really good for you to understand and put together all of the concepts that we read till now. You can download this code from the resources section, right? Now we'll get into the next hands-on workshop to understand more about it, or look at it in a different perspective on what all kind of variables we can use, functions we can use, etc. I would suggest you can create a new struct also for the player, and note down what is the address of the player, what is the amount that he invested also separately in a struct, right? Just so you get it, struct player will be created with, let's say, an address payable, because he can be a payable address, and let's call him investor, right? Then it will be a unsigned integer of how much he invested, right? Amount. So create array of players, right? Player, okay, array public players, right? Instead of this array, you can create like this, and then whenever a person invests, right? Whenever the person invests, instead of pushing it to the array, you will say, let's say, a player memory, a temporary struct, just like we looked at in the struct example, right? So player memory, you will say temp player, right? And then you will say temp player dot uh, who is that? Investor, right, is equal to message dot sender, and temp player dot, what is that? Temp player dot investor, and then we had temp player dot amount, right? Amount is equal to message dot value, right? So this is how you can actually create a players array using a struct concept also, right? Which means you have to change it here also. Players of index, right? Dot, okay, dot investor. That will store the address, right? So you can take that here, and this is not required anymore. Okay, so that's how you change the entire contract to use a struct of players, right? So I'll just change it to the way it was. If you want, you can always do it, right? So take this off, take this off. I just wanted to show you different methods of doing it. How do you say, different developers look at it in a different manner, right? So let me put dot investor in the next line. Okay, it'll be easier. So players of index, events winner, where is winner, address of this dot balance. What is the problem now? I expected this but got emit. Okay, semicolon was not there. So this also needs to be there, right? So that's how you change the lottery contract to work in a different way. Use a different data structure and things like that, right? So that's the concept of lottery. Hope you understood why this kind of a smart contract is required in lottery to eliminate the intermediary. How we are doing that in a programmatic manner also, right? So with that, we'll close this session. Look at it in the next section. Thank you.